Hello, guys. So I would like us to look at power series. Now, some mathematical functions may be expressed as power series, containing terms in ascending powers of the variable. For example, we have the exponential function being expressed like this in ascending powers of x, the sine function being expressed as this in ascending powers of x, cos function being expressed like this. Now, using Maclaurin series, mixed functions containing, let's say, algebraic, trigonometric, and exponential functions may be expressed solely as algebraic functions. So we would like to look at how exactly we can express algebraic, trigonometric, and exponential functions solely as algebraic functions. Now I want us to start off by derivation of the Maclaurin's theorem. Now, let the power series f of x, so we assume the power series, so let the power series f of x be equal to a naught plus a1x plus a2x squared plus a3x cubed plus a4 x raised to power 4 and so on. Okay, so let's call that our equation 1. Let's call this our equation 1. Where a0, a1, all the way to a4 are constants. Okay, so where a0 all the way to a and we are constants. Now, when x is equal to 0, and we replace that value in equation 1, what do we get? Replacing the value here, we will have that our f of 0 is equal to, so if we replace x with 0, 0, 0, we'll have that f of 0 is equal to a0. Okay. Differentiating equation 1 to get f prime of x. So differentiating 1, we will have f prime of x is equal to, the derivative of this is 0. The derivative of this will be, so we will have a1 plus 2a2x plus 3a3x squared plus, so this is raised to power 4, 4a4x cubed and so on. Now, when x is equal to 0, what will we have? So we'll have our f prime of 0 being equal to, if we replace the values of 0 here, we will have our f prime of 0 as 1, as a1. Okay, continuing the same process, differentiating now. So we can call this our equation 2. Differentiating equation 2. So what do we get? We'll get f double prime of x is equal to, the derivative of this is a constant, will be 0. Differentiating this one, we'll have 2a squared plus, differentiating the next one, we'll have 6a cubed x plus 12a raised to power 4x squared. Okay, so let's call this equation number 3. Now, when x is equal to 0, replacing the value of 0 here, we'll find that our f double prime of 0 will be equal to, so 0, 0, that will be 2a2. Okay. Differentiating now equation 3, differentiating equation 3. So this will give us f third prime of x is equal to, the derivative of this will be 0. Differentiating this will have 6a3 plus 24a4x. Okay, so when x is 0, let's call this our equation number 4. when x is 0, we will have, when x is equal to 0, we'll have our f third prime of 0 is equal to, replacing the value of x with 0 here, we'll have 6a cubed. This other side will be 0. Okay, fine. And now differentiating equation 4, differentiating equation 4, so that will give us f fourth prime of x. Sorry, so f fourth prime of x, differentiating on this side, this will give us 0. Differentiating this will be 24a4. So when x is equal to 0, we'll get that f fourth prime of 0 is equal to, f fourth prime of 0 is basically just equal to 24a4. Okay, fine. So having all these values, you can clearly see that from each term, we are able to get the values of the constant from our first f of x. We said that let our power series f of x be equal to a naught plus a1x plus a2x squared. So I want to write that again. So our f of x is equal to a naught plus a1x plus a2x squared plus a3x cubed plus a4x raised to power 4, and this goes on. Replacing the values of a naught, a1, a2. So coming here onto our first step, we can clearly see that the value of our a naught is f of 0. The value of, so here it is, the value of our a1 is f prime of 0. The value of our a2 is f double prime of 0. So a2 is f double prime of 0. All this divided by 2. The value of our a3, is f third prime of 0 divided by 6. This is our a3. And the value of our a4, is, so making a4 the subject of the formula, here we have a fourth prime of 0 over 24 is equal to a4. So replacing the values here, we have our f of x is equal to, our a naught was f of 0 plus x a1, so x f prime of 0 plus f double prime of 0. So we had f double prime of 0, and we had our value of a2. So let's just check that again. Our a2 was f double prime of 0 over 2. So f double prime of 0 over 2 plus our value of a3, f third prime of 0 over 6 plus our value of a4, here it is. So we have our value of, okay, so our value of a2 was this. We have x squared here. We have x cubed here. And here we have x raised to power 4. Then our value of a4 here is f fourth prime of 0. All this divided by 24. So if we rewrite this using the factorial notation, we'll clearly see that our f of x is equal to f naught plus x f prime of 0 plus x squared f double prime of 0, all this divided by 2 factorial, plus x cubed f third prime of 0, all this divided by 3 factorial, plus x raised to power 4 f fourth prime of 0, all this divided by 4 factorial, and so on. So this is the Maclaurin series, or the Maclaurin's theorem, that we will be using to write either exponential or trigonometric functions into ascending powers of x. Okay.